Hi, I'm ATH. Welcome to this lesson in my chemistry series on what are metals, where we'll look at the difference between the properties of metals and non-metals, as well as looking at choosing metals for particular uses. Before we start, let's head up our notepaper like this, with our name, the title and today's date. Pause if you need to get yourself organised. There are about 117 different elements or pure substances. Almost all of these, around 95 of them, are metals. We arrange the elements on the periodic table. The divide between metals and non-metals on the table isn't clear-cut. Some elements in the boundary area have some metal-like properties and some non-metal-like properties. They're known as metalloids. So drawing a line between the two can be debated, but I've drawn it here like stairs to make it easier. Metals are on the left of this line and non-metals appear on the right-hand side of the periodic table. So we know that most elements are metals, and we know that they're on the left-hand side of the periodic table. And we probably know quite a few metals from our experiences in life. But what actually makes a metal a metal? Well, there are certain properties that we use to classify an element as a metal. There are exceptions to many of these properties, but all metals show most of them. So we'll go through these a few at a time and make some notes in between. First of all, metals are shiny. The scientific word for this is lustrous, whereas non-metals tend to be dull. We do have to clarify that a little bit, as metals often react with the air and get covered in dull oxides or dirt. So it's best to say that metals are shiny or lustrous when freshly cut or polished. Metals also have high densities. That means that they're heavy for their volume. There are exceptions. For example, sodium and potassium have low densities. In fact, they can even float on water. So let's write the first two properties on our notes. Metals have high melting points and high boiling points. Because of this, metals are all solids at room temperature. Mercury is the exception here. It is in fact a liquid at room temperature. Gallium, also an exception. That melts at just under 30 degrees Celsius, so it'll actually melt in your hand. But most metals have got high melting and boiling points, whereas non-metals don't. Metals also make a ringing sound when you hit them. They're what we call sonorous. That's why we use metals for cymbals and bells and gongs, etc. So let's get our notes caught up with those properties. Metals are also electrical conductors, whereas non-metals are electrical insulators. All metals let electricity flow through them easily, whereas non-metals don't. Metals are also thermal conductors, letting heat travel through them easily, whereas non-metals are thermal insulators. Metals are ductile, malleable and strong, whereas non-metals are brittle. Ductile means that if we stretch the metal, it will be drawn out into a wire. If we tried that with a non-metal, it would break. Malleable means that you can hammer the metal into another shape. Blacksmith used to hammer iron on an anvil into shapes, for example, making horseshoes. Again, if you hit a non-metal, it will shatter as it's brittle. Metals are also strong. That's one of the main properties that we use them for. There are a few exceptions, however. For example, sodium and potassium can be cut with a knife. Another property that's often attributed to metals is that they're magnetic. I don't like that one, and we're going to write that one in brackets. The reason for this is that of the 95 elemental metals, only 3 are magnetic: iron, cobalt and nickel. And they sit together on the periodic table. All the other metals are non-magnetic, so it's not a very good property. All of the properties that we've been looking at up to now and noting down are what we call physical properties. That's properties about how it looks or feels, characteristics of the material that are not to do with its chemical behaviour. There is one chemical property of metals that we need to know. Metals, when heated with oxygen, produce oxides, and oxides of metals are alkaline, whereas non-metals produce acidic oxides. So let's have a look at that in the lab. So I have here some plain water and I'm adding some universal indicator, and because the water's neutral you can see that the universal indicator is going a nice dark green colour. I'm now blowing through a straw, and as I blow out there's carbon dioxide, the oxide of carbon, a non-metal, in my breath, and that's now dissolving into the water, and you can see that there's a colour change. It's turning from green to yellow, so that means the carbon dioxide is acidic. So non-metals are making acidic oxides, and we can see the green to orange transition there. If we now have a look at a metal oxide, so I'm just resetting the beaker. Again, I've just got water and my universal indicator, which is green, showing it's pH 7, neutral. And I'm just going to try and set fire here to some magnesium. The magnesium is going to react with the oxygen in the air and produce magnesium oxide, a white powder. So we can see the reactions taking off here. It's very dramatic, producing a lot of white light and a lot of heat. When it's completed, I'm going to drop the magnesium oxide powder into the universal indicator, and I'm going to give it a little stir. Because you don't get very much magnesium oxide, I'm going to do that another couple of times. So I'm just going to speed the video up just to speed things along. So that's my second piece of magnesium, again reacting in the air to produce magnesium oxide, dropping that in and then just popping in one more. You can already see that there's a colour change starting to happen, but this time it's going in the opposite direction. You can see it's becoming bluer. So if we have a quick look now that that's finished, have a look at the start and the end, we can see it's gone from a green to a blue colour, showing that metals produce alkaline oxides. So for today's joke, what sort of music do wind turbines like? Wind turbines are heavy metal fans. Boom, boom. Right, let's add this chemical property to our notes and then have a go at some questions. So let's mark these questions and see how you got on. So question 1, what word means draw into a wire? So that's ductile for 1 mark. Question 2. What word means shiny? When we talk about shiny with metals, the word we use is lustrous for another mark. Question 3. What word means metallic ringing sound? Well, for a mark, it's sonorous. Question 4. What is the chemical property of non-metals? Hopefully you picked up the non there. So non-metals, their chemical property is that they have acidic oxides. So 1 mark for acidic and 1 mark for oxides. Question 5. Give 3 properties of copper that makes it useful for saucepans. So here I have put that it's a thermal conductor, which means the heat can go into the food. Secondly, that it's got a high melting point, so it's not going to melt on the stove. And thirdly, it's malleable, so we can make it into a saucepan shape. It's always good to make sure that the properties you choose are useful for that particular use. So I didn't put, for example, electrical conductivity. Copper is a very good electrical conductor, but we don't need it to be an electrical conductor to make a saucepan. So try and make sure you get properties relevant to the use that they're talking about. 3 marks, 1 for each of those. So question 6, give 3 properties of gold that makes it useful for making jewellery. So first of all, it's lustrous, it's nice and shiny. Secondly, it's malleable, which means we can shape it into the jewellery. And third, I've put it's ductile, which means that we can draw it into a wire if we're making things like chains. You could have had a few others. For example, you might have put down that it's not very reactive. That's good. That means that it's not going to oxidise. It's not therefore going to become dull. But 3 properties, so 3 marks. Total there of 11, so I hope you got most of those. So we now have a good knowledge of what makes a metal, and hence what makes a non-metal a non-metal. If we were asked to check a material to see whether it was a metal or a non-metal, the best property to use for that is electrical conductivity. That's because all metals are conductors and virtually all non-metals are insulators, as well as being very easy to carry out and not changing the material that you're using. So electrical conductivity is our key physical property when answering questions. One exception of this that we need to know about is carbon. Carbon is a non-metal that has various forms such as graphite and diamond. You'll have graphite in your pencils, although you probably won't have any carbon in diamond form. As graphite, carbon is in fact an electrical conductor, and hence it doesn't behave as a non-metal, although it has mainly non-metallic properties. It's brittle and soft and produces an acidic oxide, carbon dioxide. Questions in exams often ask about properties in the form of matching metals to their uses. For example, we use iron for bridges because it's easily shaped, it's malleable, and it's very strong. Copper is used for wiring as it's a very good electrical conductor, as well as being ductile so that we can make it into wires, and it's also strong. Copper is also used for saucepans. It's a good thermal conductor to let the heat flow into the food, as well as having a high melting point so that it doesn't melt on the stove, and it's also malleable and strong. Gold is often used for jewellery as it doesn't react. It's lustrous or shiny, it's malleable and ductile. Sometimes a metal isn't quite right for a particular job, but almost is. What we can do in that situation is to mix a few metals together to get the properties that we want. These mixtures of metals are called alloys. Iron is strong, but if you mix it with a little carbon, it becomes even stronger. Iron mixed with a little bit of carbon is the alloy steel. You may also have heard of stainless steel, which is often used for cutlery. This is only about 50% iron with other metals mixed in, mainly chromium. This alloy, stainless steel, is strong like iron, but doesn't react and produce rust iron oxide, one of iron and steel's major problems. Aluminium has a low density and therefore is great for making airplanes, where the weight is an issue. But it isn't quite strong enough, so we make aluminium with some magnesium mixed in so that the alloy produced is light and strong, as well as less flammable. It's often called duralumin, which means hard aluminium. Brass is a mixture of copper and zinc and used to make musical instruments and decorations. The alloy brass is easily machined and the mixture of the reddish brown copper with the silver coloured zinc makes brass into a nice golden colour. It's similar to bronze, which is a copper tin alloy. So let's make some final notes on alloys and then have a go at some multiple choice questions to show you your knowledge of this lesson. And then we'll tackle an exam style question to show our application of that knowledge and understanding. So good luck. So question 1. Where on the periodic table do we find non-metals? So these are found on the right-hand side. Which metal property is being able to be hammered into shape? So that is malleable. Ductile, remember, means drawing into a wire, and sonorous is a ringing sound. So which property is being drawn into a wire? So that's ductile. Which of these is a chemical property of non-metals? So that's going to be an acidic oxide. Which property makes copper useful for wiring? Now, while all three of these are properties of copper, the one that actually makes them useful for wiring is electrical conductor. What alloy is made from iron and carbon? So that's steel. Bronze is copper and tin, brass is copper and zinc, and stainless steel is iron and chromium. So let's see how you got on. Car manufacturers use steel to make the outside shell of a car. What two elements are used in the manufacture of steel? So there's 2 marks here, one for iron and one for carbon. Question 2. What is a mixture such as steel called? So that's an alloy for 1 mark. Question 3. Name 2 physical properties of steel that makes it useful for manufacturing cars. So the 2 properties, 1 mark for each, is that it is malleable, so we can shape it into the shape of a car, and then number 2, it's strong. I don't think any other of the metal properties really fits there. Question 4. Name a chemical property of metals. So there's only one that we discussed for 1 mark, and that is they produce alkaline oxides. Question 5. Describe an experiment you could carry out to prove that steel is a metal. So if you remember, our key one and easiest one to do there is to put the steel into an electrical circuit and then show that it's an electrical conductor. So we do that one because it's fairly easy to carry out without changing the steel. And I've given 2 marks there, 1 mark for using electrical conductivity and the second one for describing an experiment. Question 6. The major problem with steel is that it rusts for 1 mark. And then question 7. How do manufacturers protect steel from rusting? Well, they paint it. So they use paint to coat the steel for another mark. So there's a total of 10 marks there. I hope you did well there. Remember, you can always go back through this video again or come back later to revise this topic. Thanks for learning, take care and see you again soon.